So I'm going to solve another system of linear equations, linear equations with two unknowns in the variables x and y. Okay, I'm going to solve it by both methods, substitution and then the elimination or addition method. The substitution method, we want to isolate or solve for one of the variables in one of the equations and then substitute that result into the other equation of the system. Now, looking at this system here, it's clear that look at the second equation. It's fairly simple to solve that equation for y. If you think about solving for x in this second equation, you have to divide by 3, or in this first equation, you have to divide by 2 or 5 if you want to solve for y. So that's the approach that we'll take. Okay, so let's rewrite this equation. Now we want to solve for y. In the second equation, rewriting that down, we get 3x minus y equals 11. So we're going to add y over to the right-hand side and then subtract 11 from each side to move the 11 to the left to get the result that 3x minus 11 is equal to y. Now what we're going to do is take that expression, substitute that for y in the first equation. Okay, so rewrite the first equation down. 2x plus 5 times whatever y is equals negative 4. Now y we know is 3x minus 11 from the second equation. Substitute that in, and now we've got one equation, one unknown, which we're going to solve for x. Distribute the 5 through. We get 2x plus 15x minus 55 equals negative 4. And then we're just going to isolate x. Combine like terms, move the variables to one side, put the number terms on the other side. So we're going to add 55 to each side to get that 17x is equal to 51. Dividing both sides by 17, we're going to get that x is equal to 3. Okay, now we can solve for y by substituting 3 into our expression, our equation in which we isolated the y variable, or plug it into either equation of the system. Either way, we're going to get the same answer. Right? This is pretty direct, though. Plugging 3 in there, we get 9 minus 11. We get negative 2 for y. So our solution, we get y is negative 2, x is 3. So our ordered pair, x and y, is 3, negative 2. All right, so that's the only place where the graphs of our equations, the lines in this case, intersect. They only intersect in one place, and that is the point of intersection. It's the point that lies on the graph of each equation of our system. Okay, now the elimination method is where we want to look at the system and then look at which variable we want to try to get rid of or eliminate by multiplying one or both of the equations by appropriate numbers. Okay, so for this system, it's pretty clear that the y variable is the better one to get to cancel out. So all we have to do is multiply the second equation by 5 to do that. Okay, leave the first one alone. Rewriting it, distribute the 5 to each term on left and right. The second equation, you get 15x minus 5y equals 55. And notice now when we add each equation together, the 5y's cancel out, just giving us 17x equals 51, like before. Divide both sides by 3, or by 17, excuse me, anticipating the answer, and we get x equals 3. Then plug x equals 3 into either one of the equations, the first or the second of our system. Okay, I'll plug it into the first one now to solve for y. So we get 2 times 3 plus 5y equals negative 4. Which gives us a linear equation, one unknown. 6 plus 5y equals negative 4. Subtracting the 6 over, dividing by 5, we're going to get the same solution we had before. Y is equal negative 2. All right, so our ordered pair, x and y, are 3, 2. 3, negative 2, excuse me, is the solution of our system. And we get the same answer using elimination or substitution. So pick your favorite method, stick with that.